to balance that. So, all right, rewrite this as a decimal. 4 times 10 to the third, 3 times 10 to the second, 3 times 10, 1, 9 times 10 to the minus 1, and 1 times 10 to the minus 2. They want me to take that whole entire number and make that one big decimal. Make that one big decimal. So how do we do that? How do we make that one big decimal? Do you realize that it's just 4, 3, 3, 1, 4, 3, 3, 1, point 9, 1. Do you see that? That's what they're wanting you to see. Let me go over here and write it. Let me write the number again. 4331.9. Well, let's talk about it. The 9 is in the what's place. This is decimals now. So this section of the course we're in is fractions and decimals, right? Fractions and decimals are kind of transitioning to decimals now. So you know about decimals, right? What's the first place after the decimal point? What's that called? The first spot after the decimal point? Tenths. The tenths, yeah. You know this is the tenths place. And then the 1 is in the what's place? Hundredths. Remember that? Remember the names? And then this is in the ones. The first 3 is in the tens. The next 3 is in the hundreds. And the 4, that's in the thousands place, right? Place value, you know about that. We did that in other place value systems, right? We did base, all kinds of other bases. We have a base 10 system, which means all the numbers are in places that have to do with a 10, don't they? That's why it's called the decimal system. How long is a decade? 10 years, right? D-E-C in front of anything means 10. So our system is called the decimal system, means base 10 system. So another way you can write these numbers, let me do that. Another way you can write 100 is 10 to what power? Second power, right? 10 times 10 is 100, 10 squared. And another way you can write 1,000 is what? 10 to what power? Third. Right? Because 10 times 10 times 10, that would put 3 zeros at the back. That'd be 1,000. Well, you see, that's what they're doing here. They're saying 4 in the 10 to the third place. Right? 4 in the thousands place, 10 to the third. And 3 in the 10 to the seconds place. 3 in the hundreds place, 10 to the second, etc. And by the way, what's it called over here when it's the tenths place? That's 10 to what power? Negative 1. See it right there? It's 9 in the 10 to the negative 1 place. And the hundredths, right? That means 1 over 100, doesn't it? Hundredths. And so that's 10 to the minus 2. I don't know if you remember from algebra, but negative power, and you don't need to know, we're not going to do a bunch with this or anything, but negative powers flip things. Negative powers flip things. So 10 to the minus 1 means 1/10. That's what tenth means, right? It means 1/10. And this means 100. So 10 to the minus 2. 10 squared, but flipped. So anyway, long story short, they're just saying, hey, do you realize that we're just giving you the place values here? That's what's really going on. When they say this is 4 in the 10 to the third and 3 in the 10 to the second, 3, 1 is just 1, 9 in the 10 to the minus 1, and 1 in the 10 to the minus 2. They're just giving me the numbers and the place values. Like that. Good enough? Just talking about the place values. So now it says write each decimal number in numbers, each decimal in numbers, 330 and 6/10. So how am I going to write that as a decimal? 330 and 6/10.
It's going to be 330.06.
30. Yeah, is it 330.06? Because that 6 would be in the hundredths place, huh?
Yeah.
Remember the first spot is the tenths? Tenths, hundredths. Yeah, so it's right next to it. Exactly, good. Good, exactly. Good. How about, so I'm going to move on if you're good with that everything. All right. So, all right, let's try this one. Write 0.025 in words. 0.025 in words. So which will be multiple choice. Which one of those is right? They all say 25, huh? 25 what?
100,000.
Yeah, well, how you name a decimal is you name it by the last place. So this is the tenths. Remember, it starts with the tenths, right? This is the hundreds. Why doesn't it start with the oneths? Well, that's over here, right? This is the ones place. Just want to make sure we're all good, right? That's why it's tenths next. Okay. And then the 5 is in the thousandths place. Okay, so therefore, you name this decimal by the name of the last place. So let me get rid of that 7 there. Yeah. So it's 25. Yeah, it's the very first one, huh? Thousandths. 25 thousandths. That's how we name a decimal. All right. So that, I think all that you know, or you being reminded of it, you'll have no trouble with it. Now here's where this is, I'm assuming, probably something you haven't thought about before. Without performing the actual division, determine whether that represents it goes off the screen. But here's the word: terminating decimal. Does that represent a terminating decimal? First off, what is a terminating decimal? What does it mean for something to terminate?
To end the decimal.
To end, right? If you get termination notice, that's called being fired, right? You're done. So terminating decimal is an ending decimal. In other words, they want to know, does this decimal stop? Or is it one of those decimals that goes on forever? So you guys have your calculators? You can do it if you want to. But we'll need to be able to answer the question without a calculator. So feel free to, if you want to, go ahead and crank it out. You'll find that it's a decimal that goes on forever if you do that. That decimal. Now, how do I know right away? You ever given any thought to this? What about a fraction makes it become a decimal that either goes on forever or stops, terminates? So I was assuming you'd never thought about this before. Just strange math teachers think about this kind of stuff, huh?
So
What makes that happen? Anybody know?
If the top is not a factor of the bottom.
That could be involved for sure. It has. We could do a big old giant project on discovery, and it would be interesting, but we don't have time for everything. So I'm going to jump right to the point. It has to do with the denominator having only things in it that make tens, that is, 2s and 5s. If the denominator has anything other than 2s or 5s, then the decimal will go forever. Why? Because 2s and 5s make tens. And we have a decimal base 10 system. So in other words, here's the simple rule, and then I'll try to give you reasons for it. If only 2s and 5s in the denominator, if only 2s and 5s in the denominator, then the decimal will end. If there's anything else other than 2s or 5s, like that 11, here's the problem. That's how I know this decimal will go forever. Because there's an 11 down there. If anything else sneaks into the denominator other than 2s and 5s, then it's going to make the decimal go forever. You can test it out. By the way, I should have said, I'm being a little too casual, I should have said, first reduce the fraction. Because, yeah, like the point you were making is a good one. If the top goes into the bottom, that'll change. You're right. That'll change things. So first reduce the fraction. That's true. So let's say that. You're right about that. So first reduce the fraction. So after, if you can divide things. There's nothing that divides here. Nothing divides, so it's good. But first reduce it, and then once it's reduced, if there's still something in the denominator other than 2s or 5s, it's going to go forever. You can test this out. Think about, what's 1/2? What's the decimal, for 1/2? 0.5. See how it ends, right? It's only got 2 down there. 1/10, as you know, that's 0.1, huh? 1/5 is 0.2 if you do that in your calculator. Whereas 1/3, the 3s go forever, don't they? Or even 1/7. I don't know what 1/7 is, but it goes forever, whatever it is, blah, 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 forever. Basically, if you have anything in the denominator other than 2s and 5s. Why again? Because 2 times 5 makes 10. And so any amount of 2s and 5s in the denominator, even if you have several 2s, 3 2s and 2 5s, and you can have a 17, and it doesn't matter what's in the top. It has nothing to do with what's in the top. That right there, 2 times 2 times 2 times 5 times 5, 17 over that, that's going to end. That's going to end somewhere. It will not go forever because these guys are all in 10. They all divide into 10. So it's still about primes and divisibility. All those numbers go into 10. On that, yeah.
Do they have to be there together, or can it be like just a 2 and just a 5?
What do you mean by together?
Like
Oh, yeah, it can be just, yeah. Well, right here's just a 2, huh? And right here's just a 5. Yeah, so no, and you could have a cut, are you asking, could you have just 2 2s with no 5s? Yeah, that would end. That'd be 1/4, and you guys know what a fourth of a dollar is, right? 25 cents, that ends, huh? Yep. So, yeah, they don't have to both be there. You just have to not have anything else other than 2s or 5s. Yeah, good clarification. Just 2s and 5s. If you have just 2s and 5s and nothing else, or just 2s or just 5s, but nothing else. Yeah, so if there's only 2s and 5s, then the decimal will end. So does this one terminate? No. That one will go forever. Yeah?
Will they always give us the prime breakdown, or do we have to break it down?
Yeah, good question. I don't remember. Let's see. And you can see the practice exam is already out there. So if you're wondering what that is, take a look at the practice exam. You'll see what I mean. And on review day, I'll be very clear. We'll go over it. I'll show you exactly the 3 or 4 question types that I'll give you. I'll hand you in 2 parts. I'll hand you part 1, say, okay, do this without a calculator. It'll be 3 or 4 questions. Be something like that, Simple things, but still that I want to make sure you know how to do without a calculator. Then I'll give you the rest of the test with the other 20 questions or whatever, where you can use your calculator. And I'll show you. There'll be no mystery. I aim to show you exactly what I want you to know. Anyway, so this would be one of them. So, because if you had a calculator, you could just divide, hit the buttons, But do you know, without a calculator, I thought it said terminating. It doesn't. I was doing that whole spiel, and it doesn't even ask the question I was thinking. I thought it said, does this end? So it doesn't. It doesn't ask that question. All right, so I guess they won't. How do you change that to a decimal? We still would do this without a calculator, though. How would you change that to a decimal?
You just divide 1 by the 8.
Yeah, just long divide. Do you remember how to do that? Maybe it's been a while since you've done any of this kind of stuff by hand. So it's a good little review. You long divide the bottom or the denominator into the top. Remember how to convert a fraction to a decimal? So I will ask you, this is one of the ones that I would ask you to do by hand. So that would be 8 into 1. I'll keep the numbers pretty simple. I'm not expecting you to know big times tables in your head or anything. Just knowing a couple mechanics by hand. So how do I do that? 8 doesn't go into 1. How's that going to work? I can't do 8 into 1. Do you remember? Has it been a while since you've done this kind of thing? Yeah. Can I just add a 0 like that?
No, you need a decimal.
Why? Why do you have to put a decimal?
Or else you're changing the value of this.
Good. Do you know that? That's the kind of explanation you want to give to kids, because you want them to see we're not just making this up as we go along, right? That's still a 1, isn't it? That's why I add the decimal, because I haven't changed anything, right? It's still a 1. It just is more convenient for me. It looks like a 10, but we know it's really still 1. I haven't changed the problem, right? Good. And then 8 goes into 10. 1 time. Now, where do you write the 1? Remember, it's all important, right? The lineup is super important when it comes to long dividing.
You put the decimal, you mirror the decimal above the division symbol as well, and you put it after the decimal sign.
Right, well, you put it over the last digit of the number you're going into. Right, so I'm going into 10, that ends with a 0, so I put it above the 0. Exactly. Does that make sense? The last digit of what you're going into. So, I'm not just going into 1, for example. Right? 8's not going into 1, so don't put it there. 8's going into 10. There's the last digit. So then you multiply, subtract. 10 minus 8 is 2. Now, if we were wanting to go to a mixed number or something, we would stop. But we want a decimal, so you keep going. Right? I add another 0. You remember all this, right? Bring it down. 8 into 20. 2 times 16. So 4, add a 0, bring it down. 8 into 40. 5 times. And there it is. Decimal goes straight up. So it is 0.125. No surprise it ends, right? Because what's that denominator made out of? 2 times 2 times 2. So no surprise. It's a decimal that terminates. That ends. Huh? Is that good? Remember to do that? Long division, bottom and the top. All those little rules. Okay, so there we go. And what do they want? They want greatest to least. So they want Greatest to least. Greatest to least. All right, so greatest to least. So again, see how I have it all lined up? That's important. Right, we got to keep this line up here. Okay, so that's the way you compare decimals, huh? So which one of those is the biggest? Let's start by finding the biggest one. Yeah, can you see it's that last one, huh? So what you do is you just say, okay, they're 14, they're all the same to there. 2, they're all the same to there. 6, they're all the same to there. Boom. This is where they're first different. This is the spot where they first start to be distinct, different from one another, huh? So this is the biggest one. So he's number 1. Okay, the other 3 are still tied. They all have a 7 in that spot. So we go to the next spot. And these guys tie again. By the way, we got number 4 now, huh? This is the smallest one. So then it's just a matter of who's number 2, number 3. We go to the next spot. He's got nothing, which is really 0, huh? And he's got 7. So he's number 2, and he's number 3. Does that make sense? Just about the lineup like that. What if these numbers were all negative? Because that's part B, notice. And I don't want to do the whole thing. I just want to point and say and move on. What if they were all negative numbers instead of positive?
The opposite.
Exactly the opposite, right? Because if you're bigger negative, you're more negative, you're smaller actually. Right? So we just exactly reverse it. Right? Think about -3 and -1. 3 is the bigger number, but where are they on the number line? This is actually the smaller number now, isn't it? When it comes to, I'm just giving you a for instance. What if they said -3, -1, which is the smaller? The bigger negative, the more negative, is actually smaller, right? Think about money, like if you have your bank account. If you're $3 in debt, I've been there, or versus $1 in debt, this is worse off, right? That's smaller. All right. All right, so write the numbers, da-da-da. So part A, an insect has a body length about 19 hundredths of an inch. So can you write that in a decimal? 19 hundredths of an inch.
Okay, 0.19.
Yeah, is that right? Is it 0.19? How do we know if that's right?
You check the places.
Check the places. Yeah, and how does the name here is hundredths. How do they get the name? They name it by the ending place. So is that the hundredths place? It sure is. So that's perfect. Does that make sense? Simon?
Yeah, 0.
Oh, good question. Yeah, what do you think? Do we have to put that 0? Would it be okay to remove that 0?
Yes.
Is that 0 doing anything? Yeah, so totally okay to remove that 0. Now, would that be the same thing as saying zeros in a decimal never matter?
No.
Because when do they matter? How about that? Because there are times when they matter, huh? This one didn't matter. When do they matter?
They're after the decimal.
When they're after, like, what if we had decimals, and I don't think this is what you meant, but what if somebody said like that? Would that kind of a 0 matter? That one's not doing anything either, huh? So when it's like this, would it matter?
Yeah.
Yes.
Yeah, why would that matter?
Because
What would it do?
it changes the place value.
Yeah, these are in different places now. This is 9 in the whatever, tenths, hundreds, thousandths place now, huh? That'd be 19 thousandths, wouldn't it? Now, you name it by the ending place. Yeah, so that matters. Yeah, so basically, if the zeros get, if they change place values, then they matter. If they're at the very front or the very back, they're optional. They don't matter, huh? All right, good. That you know. What's the next one? Is the next one uglier? Part B there? Let's see. So, planet goes around the sun once every 381 and 22 ten-thousandths days. The word there is days. So can you write that number? 381 and 22 ten-thousandths days. Yeah, so we know it starts that way, and then a decimal. Yeah, now how do you do this part? Well, we know we want a 22. How do you know?
Because I did the how many
How many places?
place values, and
Yeah.
I just put 20 to the last.
So this is, because it's named by the ending place, huh? So this is the tenths, hundredths place, thousandths place. They say 10,000, yeah. And this is the 10,000, right there, 10, 100,000, yeah. So, right, so we know we need to go 4 places, huh? Does that make sense? Because we got to end in the 10,000ths. So that means the 22 has to end there, huh? So, yeah, 0.0022. Making sense? It's always named by the ending place. All right. And then I think number 8's the same thing, right? Yeah, I'm going to skip number 8. That's just putting them in order again. No big deal. Or furthest to the right.